SPHEREx is going to capture millions of stars and galaxies in 102 different colors, creating a unique 3D map that will reveal clues to the origins of our universe. Today, we're going to talk you through all of the tests that it has to go through before it's ready for its journey to space. This is the clean room where SPHEREx is being built and tested. We call SPHEREx our small but mighty mission because it has some really ambitious science goals. The first is that we're trying to look back in time to see what happened in the first second after the Big Bang. We also want to understand how galaxies have evolved throughout history. And finally, we're looking for water and other basic ingredients for life in the places where stars and planets are forming.
BAE Systems partnered with JPL in the design and development of SPHEREx. BAE Systems was responsible for the integration and test of the spacecraft bus, which is everything below this metal ring you see around the center of the observatory. In addition, BAE Systems built the telescope that's at the center of the SPHEREx observatory.
The SPHEREx observatory is really two pieces. There's the bottom part that we call the spacecraft, and that's really the guts of the whole thing. It has the computer, the telecom system, the control system, the solar array on the backside, and then the top part is the payload. The payload consists of the telescope itself, the thing that takes the images.
The telescope is at the heart of how SPHEREx will observe the entire night sky.
And then these cones are thermal shields that help us keep the telescope cool.
The SPHEREx telescope and the detectors are required to be very temperature stable during their observations in order to collect that science data. And they lend this very distinctive structure to a spacecraft, one that I haven't seen before in my career.
So a spacecraft is built in the clean room, but we can't do all of our testing in there. We actually have different facilities that help us mimic the different environments that the spacecraft is going to see in space. The first facility that we get to when we come out of our clean room is the thermal vacuum chamber. Here at BAE, it's called Titan. It's a special chamber where we can lock in the spacecraft, pull out the atmosphere, and mimic the vacuum of space. It also can mimic the hot and the cold of space. So if you can imagine when SPHEREx is on orbit around Earth, it's going to see the sun, but also eclipses, so it gets really hot and really cold. And we can mimic all of that in that special chamber. Down the hall over there, beyond the curtain, are three more facilities. The first is the Fiesta area. That's where we do our acoustics testing. It's a whole big party for the spacecraft. We surround the spacecraft with these giant speaker stacks, and we blast sound at it, the same sound that it's going to see when it launches into space. Behind it is the vibration lab. That's a special table where we bolt down the spacecraft and shake it in all sorts of different directions, mimicking the shaking that it's going to go through when it's launching on that rocket. And then there's the electromagnetic interference and compatibility test. It's a really quiet room that absorbs all the sound, and we put the spacecraft in there and make sure that all of its components, they all emit radio frequencies. We'll make sure that they can all live in the same environment and they don't interact with each other in a weird way. There's one last test that happens here in the clean room, and it's called the separation shock test. What we do there is that we take the spacecraft and we mount it to the payload adapter ring. We then lift up the whole stack and mimic the separation that happens between the rocket and the spacecraft. When that happens, there's this big shock event, so we want to make sure that the spacecraft survives that and also that all the pieces fit together. What I'm most looking forward to, really, it's those first few images that we're going to get from SPHEREx once it's on orbit. Whenever you see those beautiful images of space, it makes all of the pain and the long days really worth it.
Personally, I'm looking forward to seeing a successful mission with data products that the science community can use in order to advance our understanding of the world and the universe that we live in. Being able to see basically back in time. It's cool. It's like time travel, right?